68. Okay, so I'm going to start. Okay. So differentiation under integral sign. Very interesting topic. Okay, so in your screen, all of you can see this one expression. Just don't go too much in detail about this expression. I will tell everything one by one, but just listen to me for the time being. Okay, differentiation under integral sign. So what are we going to do now? We are going to differentiate under integration sign. Okay, so why do we need to do that? How are we going to do that? You will get to know, step by step. But for the timing, let's talk about Lebanese rule. So we are going to differentiate under integral sign using Lebanese rule. So what does Lebanese rule says? I'm going to read out. I'm going to explain this. So equation, let's say stress nothing. Just listen to me, okay? So what does Lebanese rule says? It says that in left hand side, what are we doing? In left hand side, you can see that there is a function. There is a function. Your function ko ki wajah se integration. You are integrating this function, and after integration you are doing differentiation of this function. Okay, so what does Leibniz rule says कि कुनै एउटा function छ त्यसको पहिला integration गरेर त्यसको differentiation गर्नु, that procedure is going to be equal to, or result from this process is going to be equal to differentiation of this function first and then integration. Okay, so what do you see here? We are differentiating this function and then we are integrating. Okay, so let me summarize this again. There is a function, त्यसको integration गरेर differentiation गर्नु या फेरि differentiation गरेर integration गर्नु, both the process will give you same result. That's what your Leibniz rule says. Okay, यति कुरा clear भयो? Okay, so after this, now let's go in detail why we have ordinary differentiation here, why we have partial differentiation here. So you all know when do we use partial derivative and when can we use ordinary derivative. So you all are aware of that, isn't it? Okay, so यहाँ हामीले यहाँ partial derivative use गरेछ, यहाँ चाहिँ ordinary derivative use गरेछ. You will tell me what is the reason behind this. Why are we doing this? Tell me. This A and B are constants, okay? This A and B are. No, that's not the reason. Yeah, partial derivative use गरेछ right hand side मा, left hand side मा ordinary derivative use गरेछ. Why so? Look at the expression itself tells you. अब चाहिँ expression लाई detail मा हेरौँ. Yes, exactly. यहाँ चाहिँ double variables छ नि. Yes, of course, you have x as well as alpha parameter. Your function is not only function of x, it is also function of alpha. दुईटा parameter को function छ. But यहाँ चाहिँ के भइरहेछ? What are you doing here? You are integrating this function, isn't it? पहिला differentiation गरेछ न, पहिला integration भइरहेछ हैन? Integration गर्दा फेरि a र b constants हो भने यो process को result जुन आउँछ, it will be function of how many parameters? Can you tell me? Only one parameter, alpha, isn't it? What is the reason? Because x will be replaced by a and b. हैन, limits of integration लगाइसकेपछि त तिमीको x term रहँदैन नि हैन integration पछि, because you're integrating with respect to x. Okay, so you are integrating with respect to x, so your x will be replaced by a and b, so your x vanishes and you are only left with alpha. तो तिमीको alpha parameter को मात्रै function छ त ordinary differentiation. यहाँ चाहिँ तिमीको x र alpha पहिला differentiation गर्नु पर्यो नि x र alpha दुईटैसँग encounter गर्नुपर्छ. So that is why we are using partial derivative here. अब अझै clear भयो? Okay, so what you have to keep this in mind, you मैले topic सबभन्दा last में यसलाई गराएर छु because there are many things which you have to be very careful about. Okay, so here when we are integrating with respect to x, you will see that integration will be in terms of x, then differentiation will be in terms of alpha. Okay, integration x को terms में छ अनि differentiation चाहिँ alpha को terms में छ. Both sides, you see both sides, differentiation is with respect to alpha and integration is with respect to x. So you have to be very careful about this process. Okay, तो हामीले variable र constant switch गर्नुपर्छ. एकचोटि alpha variable त एकचोटि x variable. Okay, integration गर्दाखेरि x variable alpha constant, differentiation गर्दाखेरि x constant alpha variable. So variable र constant switch भएको भएर you have to be very careful. Now I'm going to explain this expression again. I'm not going to explain, you will see to it on your own. Okay, look at this example. Look at this example. तब तिमीलाई एकदम clear भइहाल्छ. Your left hand side or right hand side, you can see you are going to get equal answer for one of the function, and यहाँ function मैले के लेखेको छ x plus alpha, easy function, so that you can easily make out. Okay, so you see LHS or RHS दुईटैको result 1 आउँछ. Just go through it. Clear, sir? कसैलाई confusion? Else I will start exercise. Any confusion? No. Nobody is asking anything, so I assume that nobody is having confusion. So you see, एउटा example लिँदा फेरि पनि हामीले LHS र RHS दुईटै processबाट जाँदाखेरि we got same result. So that's how your Lebanese rule is working. Now let's see why we need to use Lebanese rule. How are we going to use and where do we use? Okay. So Lebanese rule कसरी apply गर्ने? Now look at this question. Your question is integration from 0 to infinity e to the power minus ax sin bx dx over x. Okay, so look at this function. Have you done integration of this function before? Can we? Ajay, कति हेरा improper integral में solution गरेछ हैन? Yes, of course. It's very good that you remember. It's one of the standard improper integral, and there I mentioned that this question we will be doing later when we will be doing differentiation under integral sign. So same process जुन process ले example मा गरेछ म त्यही process ले explain गर्छु, but if you don't apply that process, how are you going to integrate this? Can you do by any process? तिमीले अहिलेसम्म पढेको process मध्ये तिमीले कुनै process लगाएर solve गर्न सकिन्छ यो function लाई? Yes, that's your differentiation under integral sign. त्यो त हामी अहिले गर्न गइरहेछौँ हैन? त्यो भन्दा त्यो बाहेकको अरु कुनै processले गर्न सकिया छ त? अहिलेसम्म मैले पढाएको process मध्ये कुनै उसमा हामीले हेरेछ यस्तो क्वेशनलाई कसरी डिल गर्ने? Okay, so by now, if I ask you to do it without differentiation under integral sign, it is going to be very difficult for you because of one reason. यहाँ एउटा कुरा नभएको भए यो integration सबभन्दा सजिलो हुन्थ्यो. What is that reason that it is making it difficult? What is it? Yes, exactly. It's denominator, isn't it? Its denominator is creating us problem, this x in denominator. So now I will show you how to get rid of this x from denominator using Lebanese rule. Okay, Lebanese rule use garera, we will get rid of this x and then we can easily integrate step by step. Okay, so let's go through it slowly, and we have second part also, we have deduction part also. We will discuss this later. So first step ma ke gardene, first step will be to assume whatever integral is given to you, let it be equal to I, and let's make it equation number 1 because we are going to use it later. Okay, your equation hamla science we are going to use it. So let this be given integral be I. Then we can now how many parameter function is this? Our your exercise all the questions will be depending on more two or more than two parameters, 3 4 जति पनि हुन सक्छ है. यहाँ चाहिँ तिमीहरूको 3 parameter function छ, x a and b. म्युट गरौँ है सबैजना, म्युट गरौँ. x a and b. Okay, so you have 3 parameter function. So differentiation sorry, integration is with respect to x. So x baheko parameter ki bhayo a and b. So we are going to choose one of the parameter for differentiation. त हामीसँग अहिले choice छ नि, a पनि छ b पनि छ, त कुनै एउटा parameter को respect मा गर्नु पर्यो differentiation. So we will choose one of the parameter, and in this case you can either choose a or you can choose b. यो केसमा चाहिँ तिमीले a चुज गरे पनि हुन्छ, b चुज गरे पनि हुन्छ, but there will be few questions जसमा तिमीले particularly कुनै parameter चुज गर्नुपर्छ. So we will discuss that later, हैन. So here we can either choose any one of the parameters. So I've chosen b. Why? Because I don't like minus sign. हाम्रो calculation में minus sign आओस्, I don't want to do that. So किनी a लियो भने minus sign पनि आउँछ. So I am avoiding it by taking b as a parameter. Okay, so we are going to now differentiate with respect to b. So let's apply Lebanese rule. Differentiation को लागि let's apply Lebanese rule. So this is your Lebanese rule. Now let me show you and all of you just compare. यहाँ छ नि तिमीको Lebanese rule, हैन? Lebanese rule. Just compare here. ठिक छ, यो भनेको I हैन हाम्रो, integration भनेको I भयो. So di over d alpha is equals to integration a to b del over del alpha of function with and integration with respect to x. So same भयो. Clear? We have used Lebanese rule. Okay, now let's apply it. If you face any difficulty, you can ask me that very moment. Stop me and ask me, okay? So del over del b. अब चाहिँ differentiation गर्नु पर्यो. Now you have to be very careful. You step मा चाहिँ एकदम careful हुनु पर्यो. You might make mistake here because you are used to of integrating or differentiating with respect to x only. अहिलेसम्म तिमीले x लाई नै variable मान्ने habit भएको भएर you might make mistake. Okay, so here your this whole is constant. हैन, हाम्रो variable कहाँ मात्रै छ? Your variable lies here only, sin bx. So what is the result of this differentiation? Can you tell me? Your differentiation गरिसकेपछि तिमीको के हुन्छ after solving bracket? Very good. Sin bx को मात्र differentiation गर्ने हो नि, sin bx को differentiation will give you cos bx into x, isn't it? So that's what you are going to get. So let's go through it. अनि बाकी जुन constant छ त्यो त as it is आइहाल्छ हैन. Screen hang. Okay, so तिमीको let me open it again. till then let's manage with this. Okay, let's manage with this cutout. So by differentiation, after differentiation, you will get e to the power minus ax cos bx into x over x. So x and x gets cancelled. X cancel भयो त तिमीको function के भयो e to the power minus ax cos bx. Okay, so we have got this. Okay, so अब यसको integration कसरी गर्ने? How do x gets cancelled? You are going to integrate only this. अब integration गर्नुको लागि now you are yes direct formula छ हामीसँग by parts definitely जुन direct formula छ त्यो तिमीको by parts apply गरेर आइसकेको formula हो. So I have mentioned that in my first lecture also. This formula will be के छ फर्मुला के थियो e to the power सपोज यहाँ positive a छ भने हाम्रो फर्मुलामा चाहिँ positive a छ. In that case what is the formula? E to the power x cos bx equation gives you e to the power ax a cos bx plus b sin bx हैन plus definitely over divided by a square plus b square. But here a को ठाउँमा minus छ त wherever there is a just replace it by minus a. Okay, so minus a. So you have got this after integration. अब integration कति सजिलो भयो हैन? X eliminate हुन साथ integration becomes very easy. So you have to now apply limits of integration. अब limits of integration apply गर्नु पर्यो. So what is this infinity going to give you? When you apply, yes, let me mention that all these notes are already there in your team's file. तिम्रो team's को file मा छ. So don't pay stress towards noting all this down. Note गर्नु पर्दैन. Just look at your screen. Just understand whatever is going on. Okay, just don't compel yourself for writing it down. Okay, so infinity. Apply infinity. What do you get? Quickly. What is e to the power minus infinity? 0. And 0 into all of this is this is bounded function because cos bx र sin bx को value whatever large हैन यसमा cos sin value छ -1 देखि 1 को बीचमा लागेको छ नि. So that is why 0 into bounded function is 0. 0. What about lower limit? Can you think about lower limit? What is this? 0 1 0 0 cos 0 1 what are left minus yes yes exactly. Okay, so तिमीको result मा minus आउने भयो त plus आउने भयो हैन किन आयो plus किन आयो because 0 is a lower limit, isn't it? So lower limit लगाउँदा फेरि अझै एउटा minus sign आउँछ नि. So minus becomes plus and you are going to get हैन a over a square plus b square. Okay, so have you got a result? Integration त भइसक्यो. आयो result process इदियो? Yes. Yes. Yes, exactly. हाम्रो I त आकै छैन नि. We are looking for value of I. So I you have to again yet you have to evaluate. Okay, so you need your I finally. So what are we going to do? We are going to take this db to the other side. Your db अर्को side लिएर जाम and integrating both sides. Integrating both sides. What are you going to get? What are you going to get? Give me your right hand side. A is a constant now. Integration को लागि B हाम्रो variable हो, A constant हो. So you are going to get A constant common into yes into B by A. 10 inverse b by a. That's it. एउटा कुरा missing भयो जस्तो लाग्दैन? Something is missing. What is that? Yes, exactly, plus c. यहाँ चाहिँ तिमीको indefinite. Yes, very good. Indefinite integral छ नि तिमीको है. Here you have indefinite integral. That's why you have to add c also. So plus c. Yes. So have you got a result? What do you say? Cancel out the. Have you got your I? Have you got your I? I thought this is your I you are looking for. I का value I सक्यो. Have we completed our process? We have definite integral in the beginning. हामीलाई जुन क्वेशनमा सोधेछ that is definite integral. So how can you have your answer in terms of C? Don't you think so? So what are we going to do now? We are going to find out value of C. Okay, so our process is not yet over. So we are now going to conclude our process by finding out value of C. The C को value कसरी find out गर्ने? Always take help of equation number 1. Okay. Equation number 1 use गरेर हाम्रो C को value छ. अब दिने इक्वेसन नम्बर 1 मा अलवेज इक्वल गर्नु पर्यो. हामीले इक्वेसन को a र b बाहेक प्यारामिटर त्यसलाई यु आर गोइङ टु अज्युम a या फेरि b लाइक के अजम्पसन गर्दिने एउटालाई अजम्पसन यसरी अजम्पसन गर्ने दैट यु गेट in most of the case you must get I equals to 0. सबभन्दा सजिलो क्याल्कुलेसन भनेको I 0 हैन. So I कसरी 0 बनाउने त्यसरी टार्गेट राखौं. So how can you make I 0? If not I 0 बनाउन पोसिबल छैन भने आइलाई चाहिँ सजिलै इन्टिग्रेट कसरी गर्ने त्यसरी सब्स्टिट्युसन गर्नु पर्यो. ओके, सो यहाँ नट टु सब्स्टिट्युट एनीथिङ फर a, लेट्स जस्ट सब्स्टिट्युट b इक्वल्स टु 0. b लाई मात्र 0 पुट गरे पुगिहाल्यो नि हैन. sin 0 is 0, so you get I equals, when you put b 0 भयो भने I के आन्सर? Come on. Yes, 0. Okay, so what have you got? I 0 b 0. Okay, I 0 b 0. So let's use this. Equation number बाट के आयो? When you put b equals to 0, you have got I equals to 0. So use it in equation number 2. Equation number 2 मा use गरौँ. So I को value 0, b को value 0. Then what is your c? What is your c? Again 0. C पनि 0 है. So a 0, sorry, b 0, I 0, c पनि 0. So you got your c. C त आइसक्यो. C आइसक्यो त C को इंटीग्रल को रुल पनि आइसक्यो. ओके, सो फाइनली हामीसँग रिजल्ट आयो. Yes, what a relief. Now let's look at this integral deduction part. हामीले अझै एउटा डिडक्सन बाँकी नै छ. यो क्वेशनको सेकेन्ड पार्ट बाँकी नै छ. लागि इंटीग्रल को रिजल्ट को हेल्पले हामीले यो कसरी प्रुभ गर्ने? हाउ टु प्रुभ? कम on. Come on. A 0, that's it. Yes, exactly. Okay, a la 0, b la 1. So put a equals to 0, b equals to 1. So put a b equals to 1, a 0. What is your result? 10 inverse of infinity. Why not? 10 inverse of infinity is I 5. Hence proved. Yes, exactly. So that's over. Now I'm going to summarize this. म यो सबैलाई यस म सबै समराइज गराउँछु है यो क्वेसन। ओके म सबै समराइज गराउँछु किनकि यो यसमा हामीले धेरै कुराहरू पर्यो हैन। वी फेस्ड अ lot of things, so I will summarize this again in a short. Okay, so first step मा के गर्ने, सबभन्दा पहिला हाम्रो जति पनि इंटीग्रल गिवन हुन्छ त्यो हाम्रो दुईटा प्यारामिटर या दुईटा भन्दा बढी प्यारामिटरको फर्ममा हुन्छ। one of the parameter will be x and we will have other parameters also. That it is different for in the beginning to first step ma use Lebanese rule. Lebanese rule use गरेर we will differentiate this function to one of the parameter other than x. x by कुनै एउटा प्यारामिटरले डिफरेन्शिएट गर्ने। अब त्यो प्यारामिटर कुन प्यारामिटर हो, we have to choose that parameter. यो केसमा चाहिँ a र b जुनसुकैले पनि हुन्छ, it will work हैन। बट कुनै कुनै केसमा हाम्रो a या पर्टिकुलर प्यारामिटर चुज गर्नुपर्ने हुन्छ अकॉर्डिंग टु क्वेशन। सो यहाँ हामीले सबभन्दा पहिला डिफरेन्सिएसन गरे। डिफरेन्सिएसन यो स्टेपमा डिफरेन्सिएसन गरे। डिफरेन्सिएसन गरेर हाम्रो फंक्शन सिम्प्लिफाई भयो। त्यसपछिको नेक्स्ट स्टेपमा हामीले इन्टिग्रेट गरे। आवाज आइरहेछ मेरो? आवाज आइरहेछ? ओके 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 त्यसपछि हजुर yes, that's important question. Now tell me, is this a given value 1 and to b given value 2 कि एक्चुअली कि यो कांस्टेंट हो त? त हामीले इंटीग्रेशन गर्दा फेरि हामीले इंटीग्रेशन गर्दा फेरि हामीले a र b लाई, किनकि हामीले x को रेस्पेक्टमा इंटीग्रेशन गरिरहेछ त a र b लाई हामीले कांस्टेंट मानेर इंटीग्रेशन गर्यो। तर यो एक्चुअल कांस्टेंट त हैन नि। a र b लाई हामीले जुन भ्यालु पनि दिन मिल्छ नि हैन, जुन हाम्रो रिजल्ट आउँछ त्यो रिजल्टमा हामीले a र b को के भ्यालु हुन्छ अकॉर्डिंगली तिम्रो रिजल्ट चेन्ज हुन्छ नि हैन। सो a र b प्यारामिटरको काम गरिरहेछ छैन। That's why same thing. Variable हामीले पर्टिकुलरली इंटीग्रेशन गर्दाखेरि x लाई वेरिएबल मान्यो, a र b लाई कांस्टेंट प्यारामिटर मान्यो हैन। a र b लाई हामीले फिक्स गर्यो, त्यसलाई जस्तो जुन भ्यालु छ त्यसलाई एज इट इज राखेर x लाई मात्र वेरिएबल मान्यो, x मात्र चेन्जिङ वेरिएबल मान्यो। तर सब जब हामीले डिफरेन्सिएसन गरेर चाहिँ डिफरेन्सिएसन गर्दाखेरि हामीले x लाई फिक्स राख्यो, x चेन्ज भइरहेछ न हाम्रो b मात्र चेन्ज भइरहेछ भनिरहेछ हामीले है। सो डिपेंड्स है हामीले कसको रेस्पेक्टमा गरिरहेछ, इट डिपेंड्स। ओके सो what was I saying? Okay, so you have done integration till here. यहाँ तिमीले सिम्पल इंटीग्रेशन गर्यो, लिमिट्स अफ इंटीग्रेशन अप्लाई गर्यो, you will get one result. Okay, that result belongs to di over db. Okay, so that means for evaluation of I we will again integrate both sides. So integrating you will get constant of integration also, किनकि अहिले जुन तिमीले integration गर्यो that is your indefinite integral. So what are you doing? You are differentiating once. तिमीलाई question मा के भनेछ integrate गर, but what have you done? Before integration you have done differentiation. तिमीलाई integration गर्नु भने थियो, तिमीले differentiation गरिदियो. So you are moving one step backward, isn't it? तिमीले एउटा स्टेप पछाडी लियो त तिमीले दुई स्टेप अगाडि चल्नु परेन। दैट मीन्स एकचोटी इंटीग्रेशन गर्ने ठाउँमा तिमीले दुईचोटी इंटीग्रेशन गर्नु पर्यो। सो यू हैव डन ट्वाइस इंटीग्रेशन। सो फाइनली त्यसको रिजल्ट के भयो कि तिमीहरुसँग कांस्टेंट अफ इंटीग्रेशन पनि आयो। सो योर one last step is to evaluate value of c with the help of always you are going to name this as equation number 1. So the equation number 1 लाई हेर्ने, त्यसको हेल्पले इजिली आउँछ तिमीको कांस्टेंट अफ इंटीग्रेशन। That's it. That's your final step. Okay, so अब क्लियर छ? ओके सो हामीले यसलाई डिटेलमा डिस्कस गर्यो। हाम्रो भेरिएबल र प्यारामिटर आई मिन कन्स्टेन्ट्सको कन्फ्युजन पनि क्लियर भइसक्यो। कुन कुन स्टेप गर्ने त्यो पनि क्लियर भइसक्यो, किन किन गर्ने त्यो पनि थाहा छ। ओके सो नाउ वी विल बी डुइङ सेम थिङ फर रेस्ट अफ द क्वेशन्स as well. So now I won't be go too much in detail. I will just skip few steps. I might skip few steps. Okay, so you just have to carry on with me. So yes, so next question. यो क्वेशन पनि प्रिभियस क्वेशनसँग सिमिलर जस्तै छ तर यहाँ के भयो यहाँ चाहिँ यसरी दुईटा टर्म्समा छ हैन सो यु हैव टु चोइसेस मैले चाहिँ यसलाई एज इट इज राखेर नै सल्भ गर्छु आई एम नट गोइङ टु स्प्लिट दिस इन्टु टु पार्ट्स बट यु क्यान डु वान थिङ यु क्यान स्प्लिट दिस into two parts make it two integral दुईटा इंटीग्रल बनाउन मिल्छ नि यहाँबाट हैन दुईटा इंटीग्रल बनाइसकेपछि तिमीको एउटा एउटा इंटीग्रललाई मात्रै सल्भ गरौँ एउटा इंटीग्रललाई सल्भ गरौँ अनि अर्को इंटीग्रल सिमिलरली भनेर अर्को इंटीग्रलको रिजल्ट राख्न मिल्यो you will just replace a by b for second integral isn't it okay for second integral but I am going to avoid it I will carry on with this हाम्रो few steps reduce हुन्छ यो यसरी गर्दा फेरि okay so now let me ask one question how many parameters we have other than x x by 1 2 3 parameters so in total this is 4 parameter function where x is variable for integration and rest of the parameters are constant so we have to choose one of the parameter for differentiation एउटा parameter choose गर्नु पर्यो so what will be your parameter of differentiation if you are not separating this yes you can choose a and b but for that you have to divide this integral into two parts दुईटा इंटीग्रललाई दुईटा पार्टमा डिवाइड गरेर एउटा इंटीग्रललाई मात्रै सल्भ गरेर अर्को इंटीग्रलको रिजल्ट गरे पनि हुन्छ बट हियर त्यो बट यहाँ कुरै बुझिन मैले त्यसरी न के मात्र ल्याउ न k is a common term isn't it दुईटैसँग मल्टिप्लाई भइराछ if you go for a लाई गर्यो भने b लाई काम लाग्दैन b लाई गर्यो भने a लाई काम लाग्दैन okay so let's differentiate with respect to k को रेस्पेक्टमा डिफरेन्शिएट गरौँ है तिमीले यसलाई यसरी लेख्यो भने चाहिँ सकिन्छ है minus kx cos ax divided by x dx and your second integral will be e to the power minus kx cos bx cos bx divided by x dx. So what will you do? You will say that this is integral I1, this is integral I2 and you will solve only I1. You will solve only I1 and I1 को result मा A लाई B ले replace गर्दै नि तिमीको I2 को result पनि आउँछ. So you can carry on with this also. त्यो केसमा चाहिँ त्यसरी गर्दा फेरि चाहिँ you can either choose K or A. यसलाई मात्रै गर्ने नि हैन यसलाई मात्रै यसको मात्रै सल्युसन चाहियो नि so you can either choose K or A for differentiation but जब combine गरिराछ हामीले यसलाई combine गर्दा फेरि चाहिँ you have to choose K किनकि K चाहिँ common parameter multiplication बाहिर छ नि त तिमीको K that's why okay so let's choose K and differentiate let's see what happens so let's go for it so differentiation गर्ने पर्यो K को रेस्पेक्टमा so K को रेस्पेक्टमा differentiation गर्दाखेरि only this is your variable rest is a constant the constant as it is आउने भयो नि हैन so as it is a constant छैन है next step so yes tell me यो त as it is आउँछ tell me what are you going to get after differentiation of this यसको differentiation पछि के आउँछ come on quickly yes very good e to the power minus kx yes minus sign पनि आयो minus x आयो अनि बाकी चाहिँ as it is okay so confusion हुनु भएन differentiation गर्दा फेरि so अब त x cancel भइसक्यो अब integration सजिलो छ now integration अब मैले गरेर देखाउँदैन we have just done this integration भर्खर हामीले same integration गरेछ limits of integration पनि same छ so you can apply limits of integration also so I will just give you okay just tell me यो दुईटा integration लाई solve गरिसकेपछि after you apply limits of integration you will get one function in terms of एउटा फंक्शन आउँछ नि लिमिट्स अफ इंटीग्रेशन अप्लाई गरिसकेपछि त्यो फंक्शनमा के प्यारामिटर्स हुन्छ जस्ट टेल मी quickly only k a and b आउँदैन yes of course x मात्रै हटिरहेछ नि हाम्रो त हैन लिमिट्स अफ इंटीग्रेशन लगाएर x मात्रै हट्छ नि a र b त बाकी छ नि हैन a b and k so you are going to get some function of a b and k that is going to be di over dk यो जुन some function of k a b भयो that is di over dk so you have to do one more integration एकचोटी अझै एकचोटी indefinite integral गर्नु पर्यो त्यसको रिजल्ट चाहिँ मैले देखाउँछु so its result is what is it yeah यसको रिजल्ट चाहिँ के छ this is its result I equals integration गरिसकेपछि I equals half log k square plus b square over k square plus a square plus c so you have got constant of integration you c को evaluation गर्नु पर्यो value how are we going to do that using equation number 1 I already mentioned always use equation number 1 so how are you going to play with the parameters here यो parameters हरुसँग कसरी play गर्ने that we get I easily what do you say yes you have two choices either you put k equals to infinity or you put a equals to b हैन यो गरे पनि भयो नि so you can choose any one of the process so let's put a equals to b and a equals to b राख्यो नि I0 आयो हैन I0 हुन्छ so put a equals to b here a equals to b लियौं k equals to infinity ले पनि it works but limit लगाउनु पर्यो हैन लिमिट लगाउनु पर्यो इन्फिनिट ले यसै डिवाइड गर्नु पर्यो k स्क्वायर कमन लिने डिवाइड गर्ने you will get 1 plus 0 which is again log 1 so you will get 0 0 and c what is your c here a equals to b राख्दा फेरि log 1 भयो again you get 0 here log 1 is 0 so what is the c here c is also 0 so यो केसमा पनि तिमीको c को भ्यालु 0 आयो in second question also okay so put c equals to 0 and write down your result any doubt you can ask me okay let's look at this question how are you going to apply Lebanese rule here I mean which parameter you are going to choose here for differentiation x बाहेकको के छ हामीसँग parameter a पनि छ b पनि छ so which parameter you will choose here come on yes very good जुन गर्दा पनि हुन्छ यो केसमा why because you want to eliminate this log from your integration okay you want to eliminate this log because this log is creating us problem we don't like this log here okay so to eliminate the log from your function you can choose a square choose gare pani bhayo b square choose gare pani sorry b choose gare pani bhayo whatever okay so let's choose a यहाँ मैले a choose gare you can choose b also and carry on so let's differentiate with respect to a and after differentiation you are going to get this so I'm not going to explain now you just have a look on your own after हेरौं कसरी भयो differentiation okay it's still let me talk about this isn't this log of some function so when you when you differentiate this what will happen first step 1 over that function so आयो denominator मा आयो तिमीको 5 and then you will apply chain rule yes then you will apply chain rule so chain rule भनेको 5 dash यो जुन function छ त्यसको differentiation now यो function को differentiation गर्दा फेरि this whole is constant it gives you 0 हैन only your variable lies here. Your variable lies here. A matri hoti meko variable. X is also constant, so this will come as it is. So cos square x as it is आयो and a square को differentiation is 2a. आफै हेर्ने भनेको but I explained it. Okay. Now what next? This is a standard integral. यो तिमीको standard 12th standard मा पढेको integral खालको छ हैन. So what are you going to do here? Here you will just multiply numerator and denominator by sec square x. So what's the use of this? It is going to convert your denominator into 10. Okay, so 10 मा convert हुन्छ. भयो 10 मा convert. What is the next step? After this step, come on. Yes. Yes, of course. Either you put b 10x equals to 80 or you simply put 10x equals to t. जसरी पनि एउटै result आउँछ हैन 10x equals to t लिए पनि भयो. So let's take 10x equals to t and we will get this. Just go through it. आफै हेरौँ है आफै हेरौँ. I will till here your blue bracket सम्म आफै हेरौँ त कसरी के भयो. Done? बुझ्या छ? यो स्टेप बुझ्यो? Okay, so that means everything is clear. Limits of integration पण change भयो. हाम्रो integral पण change भयो. Now, have you done this type of integration before? I assure you, you have done this. There is only one word which is going to guide you to integrate this. What is that? Yes, very good. Partial fraction. So what are you going to do here? You are going to apply partial fraction for this solution. Okay. यसको लागि चाहिँ partial fraction apply गरेर you are going to separate this into two integrals. You are going to separate this into two integrals. अब म चाहिँ separate भइसकेको पछिको result, I mean partial fraction भइसके पछिको step म भन्दैछु है. Let me mention that. Okay, so I'm going to neglect this 2a for a while. Partial fraction गर्नको लागि यो 2a constant हो हामीलाई integration मा चाहिएन, so I'm going to neglect this. So I'm going to consider this only. यो function लाई मैले partial fraction गरेर के आउँछ I'm going to tell you that. Okay, so 1 over something that you will make out b square over a square plus b square t square minus 1 over 1 plus t square. Now just simplify this and tell me what will be your 1 over something. Very good. B square minus a square. Okay, so your jun timeko expressions of 1 over whole of this can be written as in this way. Okay, so your expression लाई यसरी लेख्न मिल्यो. यसरी लेखेपछि त तिमीको integration एकदम सजिलो भइहाल्यो नि हैन. Direct integration. Just apply integration now. Apply integration. Direct formula छ नि हैन. So I'm leaving it here. Clear to everyone? Okay. So you have to apply partial fraction here. Yes, definitely you will integrate. मैले भर्खर भने integration सजिलो छ, formula direct लाग्छ. Integration गरिसकेपछि जुन तिमीको result आउँछ, that result will be in terms of a and b because t gets vanished. T को ठाउँमा 0 र infinity ले replace गर्छ त तिमीहरुसँग a र b मात्रै बाँकी रह्यो. This some function of a and b is di over dA. हामीहरूले एकचोटी मात्र integration गर्यो नि अहिलेसम्म हैन, एकचोटी मात्र definite integral. Now we have to do indefinite integral. So after doing indefinite integral we will get this result. I equals pi times log a plus b plus c. Now you have to evaluate this value of c. So कसरी evaluate गर्ने? Let's look at equation number 1. Okay, tell me. You will tell me how. A ला assume गर्ने कि B ला assume गर्ने कि दुवैलाई assume गर्ने? What? What will you do? Very good. A equals to B assume गरे पनि आउँछ हैन? आउँछ. Equals to 1 गरे पनि अझै छिटो आउँछ. Okay? You are going to get value of C if you assume A equals to B only also. तिमीले A equals to B मात्रै assume गरे पनि आउँछ, तर तिमीले integration गर्नुपर्छ नि हैन त्यो केसमा, किनकि 0 भएर आउँदैन नि, log 1 भएर आउँदैन. So log 1 बनाउनको लागि तिमीले यो दुईटालाई 1 लियो भने झन् छिटो आन्सर आउँछ तिमीको. Okay, so when you put this you will get I equals 0. अनि अगाडि के गर्ने हो? You know. So I'm going to leave it here. So I'm going to discuss this question part only here. In this case, we are going to just discuss your parameter of differentiation. Integration part is similar to your previous question. यहाँ हामीले जुन previous question मा partial fraction apply गर्यो, यहाँ यो question पनि त्यस्तै partial fraction apply गर्ने form मा आउँछ. So you will apply partial fraction for this one also. Let's just discuss what will be your parameter of differentiation. Look at the function. Look at function log 1 plus a square x square divided by 1 plus b square x square. So you have log in numerator only. So यहाँ चाहिँ parameter a b दुईटै जुन ले पनि हुन्छ कि you have to particularly choose one of the parameter. a गर्दा सजिलो हैन, a नै गर्नु पर्यो. You have, yes, a नै गर्ने हो. Why? Because you want to get rid of this log. Okay, तिमीले b choose गर्यो भने त log as it is रहन्छ नि. So कसरी integration गर्ने त b को respect मा differentiation गरेर. Okay, so choose a. Who is this? Your question I mean last month discuss गरौँ. It's slightly lengthy. Let's discuss this first. Okay. So यहाँ चाहिँ के भनेको छ? I is equals to 0 to pi by 2 log of a plus b sin x over a minus b sin x dx over sin x. This is a function. अब यसमा चाहिँ parameter choose गर्नु पर्यो. First step. Which parameter you are going to choose? A choose गर्ने कि B choose गर्ने कि? A or B, anyone? Okay, why B? Why B? Very good. Okay, so here we are going to choose B parameter. What is the reason? The reason is we will get rid of log as well as the sin x. Okay, यो जुन denominator मा sin x छ नि, यसले पनि हामीलाई प्रब्लम गरिरहेछ. यो log मात्रै हैन. A choose गर्यो भने log मात्रै एलिमिनेट हुन्छ, B choose गर्यो भने sin x पनि एलिमिनेट हुन्छ. So एउटा तीरले दुईटा निशाना हैन. So we will choose B as our parameter of differentiation. So I'm going to tell you only first step. यसपछि एकदम सजिलो भएर आउँछ तिमीको जुन integral part छ है. कसरी I will tell you. Okay, so you're choosing B as your parameter. So first step मा के हुन्छ? This is your phi log of some function. So sin x the constant भयो नि हाम्रो differentiation को लागि. So as it is, sin x is constant, it will come as it is, no changes here. So let's keep it aside. Now log of phi gives you 1 over phi first step and then phi dash. Okay, so this is your 1 over phi, reciprocal of this phi. You can see this is reciprocal, denominator numerator exchange भयो हैन. So 1 over phi भयो यो first step. Next step मा चाहिँ phi dash भनेको अब हामीले quotient rule लगाउनु पर्यो. Quotient rule means this is your denominator square. Quotient rule, we are applying quotient rule. Denominator square and this is your denominator into derivative of numerator. This is derivative of numerator minus numerator into derivative of denominator. Okay, so that's a quotient rule. And while I was checking your assessment answer sheets. I'm talking about another section. I realized that few students have done mistake in applying quotient rule also. My goodness, isn't it a shame? तिमीले quotient rule पनि correct apply गर्न सक्दैन? Okay, so you see, after doing this, your functions become very simplified because sin x, your sin x common आएर sin x सँग cancel out हुन्छ. Okay, sin x gets cancelled. This numerator a minus b sin x and this power gets cancelled. And when you simplify this expression, your sin x like by common simplify गरिसकेपछि यो b sin x र b sin x पनि cancel हुन्छ. So you're left with only few terms, limited terms, easy integration. I'm leaving it here. Okay, you can carry on with this. So now let's come to this one. I equals 0 to pi by 2 log of 1 plus cos k cos x over cos x. Okay, so तिमीहरुको यहाँ only one parameter. We have only one parameter, so choose गर्ने पर्दैन. Simply in differentiating with respect to k. Okay, so differentiating with respect to k. Next step, look at it on your own. I'm not going to say anything. Clear, sir? Okay. The sin k is a constant. अब चाहिँ integration गर्नु पर्यो नि हामीले हैन? Differentiation done. Now we have to integrate. Integration गर्नको लागि sin k is a constant. We can take it outside. So हामीसँग integration को function के मात्रै भयो? 1 plus some constant into cos x, isn't it? This cos k is a constant. Let's call it a. यसलाई चाहिँ हामीले a भनौं न है. हाम्रो एकदम सजिलो हेर्नलाई सजिलो होस् भनेर let's call it a for a while. So this is dx over 1 plus a cos x. Do you know how to integrate this type of function? If you have cos x or sin x here. Yes. Double half angle formula लगाइदिने हैन? Very good. Half angle formula लगाएर यसलाई square मा convert गर्नु पर्यो, isn't it? Like this. यसरी गरे पनि भयो है? यसरी गरे पनि हुन्छ. हैन? त sec square x आफै आउँछ. So you see, cos x can be written in this way. Cos x can be written like this. Okay, 1 minus 10 square x by 2 divided by 1 plus 10 square x by 2. Okay, so you go both ways. यहाँबाट यहाँ पनि लिएर आउँ न. Just calculate it with using mind calculation. Mind calculation गरौँ quickly. You can see that you are going to get cos x. Okay, cos x. Now it's a few steps ma simplification matray cha. There is only simplification so I want you to look at it on your own. Next step ma ke garyo यो जुन denominator को 1 plus 10 square x छ यसलाई 1 सँग पनि multiply गर्नु पर्यो अनि simplify गर्दाखेरि numerator मा पनि लिएर जानु पर्यो. So this is it. Okay, this is it. यसपछिको step मा के छ 10 square x by 2 10 square x by 2 लाई एउटा ठाउँमा राख्यो त यसको कोएफिसिएन्ट लाई कम्बाइन गर्यो. So you are going to get 1 minus cos k as its coefficient. So just look at it quickly. Done? Okay. अब यो जुन क्वेशन छ यो एकदम सजिलो क्वेशन हो तर यो यस cos k ले गर्दा मात्रै cos k र sin k ले गर्दा मात्रै कम्प्लिकेटेड देखेको. अदरवाइज इट्स अ भेरी इजी क्वेशन. त यसमा यो कन्स्टेन्ट नभएर a र b नभएर cos k sin k को टर्ममा भएर it seems to be heavy but it's not that difficult, है? So यो जुन 10 square x छ it is not liking this k term. यो cos k लाई यसले हटाइदियो आफ्नो साइडबाट हटाउन खोज्छ. So it will go and meet with his or her friends, है? आफ्नो फ्रेन्ड सँग गयो. So cos k लाई के गर्दिने let's take it common. सो 1 माइनस कॉस के ला कॉमन लिँदा फेरि यो यसको डिनोमिनेटरमा पनि जाने भयो sin k को डिनोमिनेटरमा पनि जाने भयो. So what is going to happen now? What will happen? They are going to combine, हैन. 10x सँग पो मिलेन, अरुसँग त मिल्नु पर्यो नि, हैन. So what are you going to get? You are going to get 1 plus cos k upon 1 minus cos k and minus sin k over 1 minus cos k. So यहाँबाट हट्यो. So what is 1 plus cos k over 1 minus cos k? What is it? Isn't it 2 times cos square k by 2 divided by 2 times 1 minus cos k is? Okay, so yo भयो. Oh, what I did a mistake. Yes, I've written cos x only here also. It's sine. हैन त यो तिमीको के भयो एक्सप्रेसन सिम्प्लिफाई भएर? What is this? What is this? What is this? Yes, not tan, cot. Cos माथि छ नि त हैन? So you will get cot square k by 2. Cot square k by 2. Similarly, sin k over 1 minus cos k will give you. Evaluate this. Yes, exactly. Cot k by 2. हैन, cot k by 2. So यसपछिको स्टेपमा cot k by 2 आउँछ. So let me just copy this expression and show you next step. One more thing. You the cot k by 2 भयो. Now this is sec square x by sec square x dx over, let's call it a square. एउटा constant मानौं. So isn't this a standard integral? How will you integrate this? Quickly. How will you integrate this? Come on. Yes. 10x लाई t assume गर्ने नि, sec square x dx dt हुन्छ हैन? Definitely x by 2, so I'm calling it just x. Okay, 10x लाई t मान्यो भने sec square x dx will be dt. So what are you going to get? Okay, so this is a previous step. I'm copying it here to show you your comparison so that you can compare with next step. So तिमीको उ पनि भयो. What have you done? You have done substitution also, हैन? Substitution पनि apply भइसक्यो. So 10 को ठाउँमा t, sec square x dx को ठाउँमा dt, and x by 2 भएको भएर यहाँ 2 dt आयो हैन? 2 dt. So यहाँसम्म क्लियर छ? न यसको इंटीग्रेशन क्यों नहीं भयो? यसको इंटीग्रेशन क्यों नहीं भयो? What will be integration of this? Come on quickly. Very good. A को ठाउँमा cot k by 2 मात्रै त हो नि हैन? So 1 by a tan inverse t by a. 1 by a tan inverse t by a. So got it. Okay, so you see many of the terms gets cancelled, and can you tell me is पछिको next step मा के आउँछ हाम्रो result? What is di over dk? Simplify this whole. What is your di over dk? Think about it. -1 आउँदैन, you are very close. You cannot have constant answer. Minus k, yes, exactly. Your 2 सँग cancel out हुन्छ नि. Okay, So minus k, my goodness, it's so frustrating. Itro lama calculation garara minus k matre, right? So you see, we have gone through a lot and we have just got minus k. Okay, so minus k matre aaya hamro result. Okay, अब इस पछि को step you know. di over dk छ त फेरि इंटीग्रेट गर्नु पर्यो, constant of integration evaluate गर्नु पर्यो. Constant of integration कसरी evaluate गर्ने? Use this and tell me what will be your substitution for k. My final question. Yes, very good. K equals pi by 2. K ला pi by 2 लियो भने तिमीको I 0 हुन्छ हैन? K ला pi by 2 लिने I 0 हुन्छ. So what is the C? यो केसमा C कति आयो तिमीको? Come on. Very good. Pi square by 8. That's it. Okay, you have got your C also. So you have got your I also. So maybe this is for the first time we have got C other than 0 हैन? हामीले हेरेकोमा 0 बाहेकको other value आयो C को हैन? So your I is, finally your I is pi square by 8 minus k square by 2. So that's your final answer. Yes, that's it. That's it. Siddharth differentiation under integral sign. So for AB section, it's the end of course. And for aerospace, we will be conducting few more classes. We will decide next week and we will complete course. Okay. All right. So any queries?